In an electrical power distribution system, a solid neutral refers to a specific type of neutral conductor characterized by several key attributes. Firstly, it is continuously connected to a ground reference point. This means that the neutral conductor is always electrically tied to the earth, providing a stable and reliable reference for voltage levels throughout the system. Secondly, a neutral conductor is connected to ground at the power source, which is typically a transformer, and at multiple points along its length. These connections ensure that the neutral remains close to ground potential, minimizing voltage differences and providing a safe path for fault currents to flow. Thirdly, the neutral conductor carries the unbalanced current that flows in an electrical system due to differences in loads on the phase conductors. In a balanced three-phase system, the currents in each phase are equal and opposite, resulting in zero net current in the neutral. However, in reality, loads are rarely perfectly balanced, and the neutral conductor carries the residual current. Fourthly, unlike a grounded neutral, a solid neutral is not connected directly to earth grounds at the load side. This isolation helps prevent ground loops and interference from other grounding systems. The purpose of a solid neutral is multifaceted, primarily focusing on safety and stability. In terms of safety, by continuously grounding the neutral, the solid neutral provides a low impedance path for fault currents to flow. This prevents dangerous voltage build-up on the neutral conductor, which could pose a risk of electric shock or fire. Furthermore, it enables protective devices, such as circuit breakers and fuses, to quickly detect and interrupt fault currents, minimizing damage and enhancing safety. For stability, the neutral conductor helps balance voltage levels across the system, ensuring stability and preventing voltage fluctuations. This is particularly important in systems with nonlinear loads, which can generate harmonic currents that can distort voltage waveforms. Moreover, the solid neutral provides a stable reference point for voltage regulation, ensuring that voltage levels remain within acceptable limits. In terms of isolation from earth grounds, a solid neutral is not intentionally grounded at the load side, which helps isolate the system from other grounding systems such as lightning protection grounds. This prevents unwanted currents from flowing between different grounding systems, which can cause interference and equipment damage. Some advantages of a solid neutral are improved safety, which means reduced risk of electrical shock and fire hazards due to fault currents. The continuous grounding of the neutral provides a low impedance path for fault currents, enabling protective devices to quickly detect and interrupt faults. Enhanced stability refers to ensuring voltage balance and preventing excessive voltage swings. The neutral conductor helps balance voltage levels across the system, minimizing voltage fluctuations and ensuring stable operation of equipment. Isolation from lightning surges prevents surges from entering the system through lightning protection grounds. The isolation of the neutral from earth grounds at the load side prevents unwanted currents from flowing between different grounding systems. Some disadvantages of a solid neutral are higher touch voltage. The potential voltage between the neutral conductor and ground can be higher than that of a grounded neutral, which can increase the risk of electrical shock in certain cases. Unintentional ground loops can occur if the neutral conductor is not properly installed and maintained. It can create ground loops that can lead to voltage instability and equipment damage. Ground loops are unwanted current paths that can cause interference and voltage fluctuations. Solid neutrals are commonly used in commercial and industrial power distribution systems, where safety and stability are paramount. They are typically employed in systems with high fault currents or where isolation from other grounding systems is required.